University of Tokyo. And about the supernumerary robotic limbs, the famous one is proposed by the professors in MIT. This is some illustration of the robotic limbs that it can in very huge size. That is like the third or the fourth hand for a fourth arm for the normal users that can help you in daily tasks that can be quite strong in human augmentation purpose. So we consider this kind of research as our start point, but we think what it is not good for this kind of device. First, that the device mostly has some limit to achieve the range. For example, like this. So if you want to achieve in far distance, so you should move the user, the user should move because it cannot achieve a very far distance. The another thing is that when you wear it, it's quite not suitable for some daily life. If you use it for when you walk, or for example, walk through the narrow door, it is quite not inconvenient because it is very big, especially in huge size. Right now, this is just an example of the wearable robot arm. This is need very few size. For example, for larger size, it is quite inconvenient. So this is our work in last year, also in this conference in the augmented humans. We propose this device. This is the wearable robot arm. We use it. It can be very compact. That when the user uses it, it can be in small size. Also, it can be extendable, so it can be more longer. So the problem of this, our previous work, is that it is have very few degree of freedom. It's only 3 DOF, so it is a lot flexible. The next thing is that we can see that here we use the sister structure for the extendable mechanism. It is not stable. When you use it, you cannot use it in very especially for the grip. If you want to take something, it's quite difficult. So when we get the inspiration from some extendable robot arm like this, they use the double sister structure, like in the right figure. They use this structure that can take something very far away. Also, it can be extendable, that can achieve very long distance. This is also a robot arm. This robot arm is proposed by the same group in MIT. So we inspired from this idea. We think compared to the previous work of the bigger size or very large, also that is maybe will not inconvenience when you wear it in all day. So we want to make it very compact. So this is our motivation. So in that sense, we made this device. So this is our initial design. So compared to last year, we used the double sister structure here. This is double sister structure, more stable. Also, we increased the degree of freedom. Right now, we have the 7 DOF, the 7. So we have the 7 joints. I will introduce the one by one. So this is in compact state. So it's very in small size. When it can expand it can achieve quite a long distance. It's almost 2.5 times longer than the human forearms. So this is our system. We have the 4 joints. Actually, this is the base. We have the short joint. We have R is the rotation. T is the transform. So we have also we have wrist joint and elbow joint. Here in the middle size is the extension joint. It can become longer. Also, we have the grip. We use the servo motor here. This is the red color. In the small size is a DC motor. So we use the almost 3D. I think it's three DC motor here. So this is the design in different aspects. It is a compact state. So it can be. So this is our prototype. We make it. We use the 3D printer to print all the solid sides, and also we use the servo motor and DC motor here. We make it. So here is the fabrication result. This is use double system structure. When we extend it, it can be extended quite a long time. That is almost it's almost 3 times longer than the original. So this is the short joint. This is our simulation result. First is the short joint. It can rotate it. Then this is the short joint for twisting. You can twist it in different angles. And this is the elbow joint. Elbow joint can here. This is the wrist joint for rotation. So you can achieve the wide range distance. Also, this is the wrist joint for twist. I think this is animation here. Here, this is the simulation result. Also, another joint is here. This is extension joint. When we use, because we use double system structure, we just have one DC motor here. When we use DC motor, it can extend in very long distance. Here is the DC motor. This is our prototype. Yes. And this is for each joint, for shoulder joint and wrist joint. And also this is for twist motions. Also it can twist for different joints. Can be extendable in quite a long distance. This is the grip. We have some applications. For example, when the user walk through the large door, it will be inconvenient when you wear a robot arm. So maybe the robot arm can recognize the environment and will be transformed into compact sizes so that the user can just walk through the door very successfully. I should mention that this is just controlled manually. Right now we work on how to make it automatically for use some different biosingles. Another example is here, for example, for cooking. Maybe in future, this kind of robot arm can help you in the cooking, and when you don't want to use it, they will just come back into your body, just come back into body and don't interference in your work. This is for cooking. Also, we use it for working. For example, when you're quite busy for some work, it can help you to take the object and take it for you. And when you finish it, they will just come back and just nothing happens. So this is our future visions. Because for robot arms, every robot arm is very big. It is comfortable when you wear it. So I think in the future, this kind of robot arm, just like your smartphone, like your iPhone, you can wear it every day, and also that is can suitable for all users. It is for child, for disabled people, for women, for it can for any task for cooking. So I think this is our future vision. That's all for my talk. Yes, thank you very much.